So we're going to continue to solve quadratic equations using methods of factoring. We know how to solve a quadratic equation if the equation is ax squared plus bx plus c equals to 0. If a, b, and c are integers and it is factorable, then we can solve it. Right? We had this discussion yesterday, what if it's not factorable? Well, we'll get to that later. But the bottom line is if it's factorable and those numbers are integers, then we can do it. What our goal today is to take questions like A, where it turns out it's going to be factorable, but the coefficient of x squared is not an integer. Like B, where the coefficients are decimals and not integers. Same thing. Fractions, not integers. We'll talk about that one later. Our goal is for A through E, I believe, to turn these equations into something that falls into this category. We're just going to have to use our math skills to turn this equation in A into a quadratic equation where the coefficients are integers, and then we can factor it. So how do we do that? Well, I'm going to rewrite this, and I would recommend you rewriting it this way. And you might say, well, I haven't really rewritten it differently. I want you to notice the subtle difference of where that x squared is written. We talked a lot about this morning in Math 30-1 when we work with trigonometric expressions. If something is not a fraction, put it where it would be if it were a fraction. X squared is x squared over 1. So, I mean, I don't have to do this, and I'm not going to. I'm going to erase what I'm going to write, but I could write it this way. All I'm pointing out to you is line things up vertically where they belong. And what I would say to you is that the reason we cannot solve this equation is because we have a fraction here. Now, our goal becomes to get rid of the fraction. You can't just erase it. Right? Like you can't just go, well, let's just erase it then. Hey, we got rid of it. You have to use a mathematical operation on it that is fair across the whole equation. And the operation is going to be, I'm going to multiply both sides of the equation by 4. So what I'm going to actually be doing is taking 4 times 1/4 x squared and subtracting 4 times 2x and setting it equal to 4 times 12. So I'm multiplying both sides of the equation by 4, and that translates to a fair multiplication of multiplying everything by 4. Multiplying the quadratic term, the linear term, and the constant term all by 4. So what happens when I multiply the 1/4 x squared by 4 is the 4 over the 4 cancels, and I forgot my squared there, didn't I? The 4 over the 4 cancels, and I'm left with x squared. 4 times 2x is 8x equals 48. 4 times 12. And I want you to stop here because I know that you can get the answer now, but I want to point out that you can get the answer. I want to point out, this is my philosophy in math education. You take a question or a problem that you do not know how to solve, and you turn it into a simpler question that you do know how to solve. In other words, you take something from today and you turn it into something from yesterday. Does that make sense? So how do we solve this? Well, we learned yesterday that what you want to do is zero the equation. And it's interesting because just before your quiz today, I think it was Ariana asked, is it just on that stuff or is it on the day before? And I said, well, no, just that stuff. But I said you could solve an equation like this with trial and error. but you don't need to. Remember that since this is 1 for a coefficient of x squared, factoring it, there's no trial and error involved. You know it's x and x, and the two numbers are going to be whatever two numbers multiply to give 48, negative 48, and add to give negative 8. Now, I suppose you could do a trial and error thing. You could say, well, okay, 48 is 8 and 6. It is. 48 is 8 and 6 in terms of a product. But if you tried to FOIL this out, you would not be able to get 8x for the middle term, negative 8x. So the two numbers end up being 12 and 4, and the 12 has to be negative because your outer will be 12x, your inner will be 4x. We want negative 8, so the outer has to be negative 12x. So we get x equals negative 4, we get x equals 12. I don't think we have to write x plus 4 equals 0. But you know what? I'm going to. I have a thought that I want to get across to you. And my thought is this. We went from... Is the speaker hissing? Just my ear, eh? We went from what I will call a difficult or tough problem to a simpler problem to stealing candy from a baby. We went from a problem that's a grade 11 difficult problem to a problem that we could solve yesterday or the day before to a problem that, quite frankly, these two statements, x plus 4 equals 0 and x minus 12 equals 0, not only could we steal candy from the baby could probably solve these problems. Well, no. Look at him. There's nothing there. X equals negative 4 and x equals 12. The point is we take math expressions and equations and problems and turn them into simpler problems. That's the goal in high school math. So what do we do here? Well, we have to get rid of the decimals. Can you factor with decimals? Yes, but it's very difficult. So the best thing to do here is to say that I'm going to multiply every term by 10. Multiplying something by 10 moves the decimal place one place to the right. And that means 0.3 would become 3, 1.8 would become 18, 8.1 would become 81. So I'm going to multiply everything by 10. What I'm showing you is the work that you would put on a written response, and also something that if you were to look back on your notes a week from now, you would understand what happened. Yeah.
Why don't you just do one big bracket?
I have something else that I want to address first. I'll get to the one big bracket. Here we multiplied everything by 4. So let me address your question. I don't have a problem with you. I need to learn how to spell tough. I don't have a problem with you doing this. Okay? I don't have a problem with you doing that. I would prefer, so why don't I? Because I chose not to. I do have a problem with you doing this. Don't do this. I want to see left side and right side separately. So, why didn't I? Because I chose not to. The question is, I think, why didn't I write what I'm about to write in green? Am I correct in understanding your question? I'll be honest, there is a reason why I do it the other way, at least to begin with. If I do it in green, some students miss some terms. It's my way as a teacher of really reinforcing that you have to multiply everything by 10. By the way, I do have to multiply the other side by 10, right? Like in the previous question, we multiplied both sides by 4. I don't know why I put a quarter there. This should be 4, right? Okay. We do have to multiply the other side by 10, so we should be writing this. But since it's 0, it's still going to be 0. And this is equivalent to when Thomas was asking, can we just get rid of the number? Since it's equal to 0, we don't really have to worry about it. It's there anyway. It's going to be 0. Anyway, regardless of whether you do the brown or the green, the result is the same and either one is acceptable. Are you good with that answer? Okay. So when I multiply, if we do the green, I go 10 times 0.3x squared. I have to distribute this with the distributive property. So I end up doing what I wrote anyway, and I get 3x squared plus 18x minus 81. Don't forget your equals 0. And now we're back in yesterday's work. This is a quiz question. This could have been on your quiz today. Is there a common factor, though? Because if there is, we should take it out and then make our life even easier than it has to be, or make it easier than it is. So I factor a 3 out. You might have to help me here. I believe you get x squared plus 6x minus 27. For whatever reason, this x squared minus 6x or plus 6x minus 27, we seem to see that combination a lot. It's 9 and 3 that are off by 6. In this case, it's positive 9 and negative 3. So 9x plus negative 3x would give us the 6x. That means x plus 9 is 0. It also means x minus 3 is 0. That means x equals negative 9 and x equals 3. And, you know, this line here, when you're just working on your own and practicing, this line, I don't care if you write that down. You don't have to write it down. Again, written response, you should write it down, because if you don't write it down on a diploma exam next year, then you won't get full marks. So you might as well get used to it now. 0.8x squared plus 4.4x plus 0.2. Well, let's multiply everything by 10. Let's do it this way this time. So I get 8x squared plus 44x plus 2 equals 0. Again, you multiply by 10. All you're doing is you're moving the decimal one place to the right, eliminating that decimal. I can take a 2 out and have left 4x squared plus 22x plus 1. We could double check here. 2 times 4 would give us the 8 in the x squared. 2 times 22 would give us the 44 as the coefficient of x. And 2 times 1 would give us the constant term. Now we're ready to factor it. Well, it's got to be 1 and 1. Doesn't it? Doesn't it have to be 1 and 1? Yes or no? For the 4x squared, it can be 2x and 2x. So if we put 2x and 2x in there, and I understand the look of consternation on your faces right now, which means the confusing look on your faces. If you put 2x and 2x, that's not going to work, is it? What about if we put 4x and 1x? So what does that tell us? Not factorable. And that's perfect. That's the perfect way to say it. It's not factorable. It doesn't mean there are no solutions. So when we use trial and error, this can be a frustrating thing. When you use trial and error, if you exhaust all of the possibilities and it's still not working, then it's not factorable. So no matter what we try, it's not factorable. But now I'm going to teach the whole class, not just a few who were paying attention near the end of yesterday's class, how you could tell if it is factorable or not. Because, let's face it, I know that some of you were confused. You're looking at this and you're going, wow, he says everything's factorable, but I can't do it. You understand how frustrating it would be to try to factor something when it's not factorable? If it's by trial and error and it's not factorable and you don't know it, man, that's confusing and frustrating. So the trick is if b squared minus 4ac equals a perfect square, it's factorable. What is a perfect square? 1, 4, which is 2 squared, 9, which is 3 squared, 16, 25. So let's calculate b squared minus 4ac. That would be 22 squared minus 4 times a, which is 4, times c, which is 1. Is it 468? I'm probably wrong. I think I lost track of my thoughts there. It is 468. Oh, okay. Is 468 a perfect square? Well, you can find out if 468 is a perfect square by taking the square root of it. And if it is a perfect square, you'll get a number like 16 or 20 or 32 or 5. So when I try to take the square root of 468, I get a decimal. That means 468 is not a perfect square, which means the thing is not factorable. And I choose this time in this lesson to teach you that because now we're going to start to see things that are not factorable. Now, are there solutions? I don't know. I guess we should graph it and find out. Because we still are expected to solve this. We just can't do it by factoring. When we graph this, you do not need to include this 2 that we factored out. We're going to ignore it. By the way, I know there's going to be solutions. If you stop, no, I don't yet. I shouldn't say that. Let's graph it. I have 2x squared, 4x squared, plus 22x, plus 2. I'm going to try zoom standard first. Well, yeah, there's X-Intercepts. So now we can go back to what we learned on the first day of this unit, which is how to solve graphically. I'm going to adjust my view here by lopping off that wasted space on the left and the right, and also starting at a lower value of y to try to bring that vertex up higher. So in my windows, I might go from -8 to 2. And I'm going to start at -50. I really don't know about the y and how far down I should start. But that looked pretty steep. It looked like it really would go down quite a ways. Regardless, I think this should be good enough for me to see it. Yep. So now we find the X-intercepts, which would be the solutions of the equation. What are we doing here? 0. Enter, go to the right. Enter a third time. One of the answers is about -5.4 something. The other one is about negative 0.09. And those are not rational numbers. You will not be able to convert them to fractions. Any questions with C? I might come back if we have time and talk more about C. Let's try this one. I guess I'm going to have to multiply both sides of the equation by 2. So I'm going to multiply 13 halves x by 2. I'm going to multiply the 5 by 2. I'm going to multiply the negative 3 halves x squared by 2. We're just getting a little bit of a workout with our algebra skills here, that's all. If you feel more comfortable putting 2 brackets, the whole thing, all the power to you. It doesn't matter. I don't know why I changed colors. The 2's cancel here, leaving us with 13x. Nothing cancels here, leaving us with 10. The 2's cancel here, leaving us with negative 3x squared. I need to zero the equation, which means I'm going to move everything to one side. I think it's a good idea to move to the left side so that we have a positive number of x squareds. To get 3x squared, boy, I'm all over the place with the colors, plus 13x minus 10 equals 0. Does that look okay? Yep.
Does it matter whether you move it over or multiply it by 2 first?
No. It's a good question. Question is, did we have to get rid of the fractions first, or could we move stuff over first? And you know, many of you, if you move stuff over first, the answer is no, it doesn't matter. If you move stuff over first, for many of you, I think it might be visually nicer. I suspect. But it doesn't matter. For many of you, it's not going to matter. But for some of you, you might want to see that equals 0 and then go, okay, now I'm going to get rid of the 2's. Okay? Hey, you know what? Just for kicks, is this factorable? I want everybody to calculate b squared minus 4ac. Keep in mind, c is a negative number, so you need to include that negative. A is 3. B is 13, C is negative 10. I believe I know what b squared minus 4ac is. I think it's 289. 289 is a perfect square. I believe it's 17 squared. And the reason why I want to maybe do that is if I'm writing an exam, well, I don't have to write exams, but you're writing an exam, these numbers look pretty awkward, don't they? I mean, trial and error is not that difficult, but what if it's not factorable? Do you want to spin your wheels sweating over something that you can't do? This is factorable, though, because this is a perfect square. So it must be 3x and x. I'm going to go out on a mathematical limb and say it's not 10 and 1, it's 5 and 2. I'm going to try it. I'm going to put the 5 here and the 2 here. That's not going to work. Because my outer is 6x and my inner is 5x, and I want a total of 13x. That's no good. So let's switch these two around. Let's see. Now my outer is 15x. My inner is 2. Well, that's good. Because if I have positive 15x and negative 2x, then that gives me 13x. And that means 3x minus 2 equals 0. It also means x plus 5 equals 0. So x equals 2/3. X equals negative 5. This is really good because it's just the first layer of the new stuff today that's new, and then we're getting more practice with the stuff that we already should know how to do. What? 25p squared minus 16. There's no p's. There's a quadratic term and a linear term. And I'm going to show you two ways to solve this. This, you need to make a mental note, is we're missing the linear term. We're not, I hope you know what I mean. We're not missing it like I've hidden it from you and we just have to find it and put it in there. There is no linear term. There is 25p squared, which is the quadratic term. There is the minus 16, which is called the constant term. It's equal to 0. There's no linear term because it's 0p, and you don't need to write this down. But this is called the linear term. And there's nothing there. So how do you solve it? Well, let me show you how to solve it with factoring. I need to take you back to grade 10, though, and I want you to just on a scrap piece of paper somewhere or off on the side, I want you to take x plus 3 times x minus 3. I want you to FOIL that out and simplify it. You get x squared minus 9? Good. So you get x squared, you get, my outer would be minus 3x, my inner is plus 3x, and my last is minus 9, which gives me x squared minus 9. Why is there no linear term here? It's because the two linear terms, the outer and the inner, are equal but opposite. Why are the two linear terms in my FOIL equal but opposite? Because these two things, might as well introduce this language to you now, are called conjugates. X plus 3 and x minus 3 are conjugates. A plus B and A minus B are conjugates. Puppy plus kitten and puppy minus kitten are conjugates. And whenever you multiply two binomial conjugates together, the outer and inner cancel, which means if you're ever multiplying conjugates, you don't have to FOIL. You FLA. You do your first and your last. That's all you have to do. I want you to notice, though, that this x squared is the square of the first term here, because it's x times x. And I want you to notice that this 9 is the square of the second term. 3 times 3 is 9. And this is what you call in grade 10 math a difference of squares. So when you go from x plus 3 times x minus 3 to x squared minus 9, you're FOILing it out. You're simplifying it. But that means if you were to go from x squared minus 9 to x plus 3x minus 3, you would be factoring it. Let's just review something else from grade 10 then. Let's take this one step further. If I said factor x squared minus 16, this is how I would teach Math 10, even though I haven't taught it in a number of years. Is this a difference of two things? Yep, minus. It's a difference. Is the first thing a perfect square? Yes. What is it the perfect square of? X. That means when you factor it, you put x here and here. Is the second thing a perfect square? Yeah. What is 16 the perfect square of? 4. So you put 4 here and here. How is this helpful? Well, how do we factor 25p squared minus 16? Is this a difference? I should back up. This was a difference, and x squared was a square. and 16 is a square, so it's a difference of squares. Is this a difference? Is 25p squared minus 16 a difference? Yeah, because it's minus. Is 25p squared a perfect square? Of what? And what that means is, what would you square to get 25p squared? Well, 5p. Is 16 a perfect square? Yeah. Of 4? So this is the factored form. By the way, it doesn't matter the order that you write those two factors in. You could put the 5p minus 4 first or second. And we're done. So, well, we're not quite done. 5p plus 4 equals 0. 5p minus 4 equals 0. So p equals negative 4/5. P equals 4/5. Capiche? Does that make sense? Now, I said I would show you a different way to do it. The factoring way won't always work. So I'm going to show you a different way in a minute. Let's take a look at this next one. 0.36 minus 0.81x squared. Let's get rid of the decimals. Let's get rid of the decimals. Decimals are, they're hard on the head, especially when it comes to factoring. So I'm going to have to multiply by 100. And I have to multiply the other side by 100 as well. I know that you know it's still going to be equal to 0, but you should write it down. I'm multiplying by 100 because I have two decimal places that I've got to clear. This 100 will move the decimal 2 places to the right, which is 36, minus 2 places to the right, 81x squared. Is that a difference of squares? Yes, it's a difference because of the minus between the terms, and of squares because 36 is a perfect square of 6, and 81x squared is the perfect square of 9x. So I can factor it into 6 plus 9x and 6 minus 9x. Before I go on, how many of you would have moved everything to the other side so you have positive x squareds? Okay, so let's address that. If you move everything to the other side, sooner or later you're going to have to get used to sometimes working with negative x squareds. But if you move everything to the other side, which, you know, in retrospect, if I would have occurred to me, I would have done it. I think it's the smarter thing to do. You would end up with positive 81x squared minus 36 equals 0. Well, you can put the equals 0 on whatever side you want. Do you get my point, though? Is this still a difference of squares? Still is, right? It's going to factor into 9x plus 6 and 9x minus 6. But we can solve either of these. If you go 6 plus 9x equals 0 and solve it, and 6 minus 9x equals 0 and solve it, you're going to get the same answers that you would get if you set these two equal to 0. Okay? You're going to get for one of them x equals negative 6 over 9, and x equals, see, I'd move the 9x over here. 6 equals 9x, then get x equals positive 6 over 9. By the way, 6 over 9 reduces to 2/3. So your answers here are x equals 2/3 and negative 2/3. Is G the last question? No? Okay. And we can write this as x equals plus or minus 2/3. By the way, I'm guilty of doing a couple of things not wrong here, but you know what I should have done maybe here? Is looked for a greatest common factor. Greatest common factor of 9. if you factored a 9 out first, which you really should have. I'm not putting the blame on you. I really should have factored a 9 out first. Look at the numbers. They're a lot smaller, aren't they? Is this still a difference of squares? If I set each of these factors equal to 0, boom, I get to the answer right away. I don't have to reduce 6 over 9 down. Any questions with F? G. Wait a minute. There's no constant term. This has a special solution as well. We're still going to factor this. How do you factor something like 4x squared minus 3x? Any ideas? You're not going to put two sets of brackets because then you would have to have 0 and 0 to get the constant term. You're going to factor out a common factor. There's an x in each of those terms. I can factor x out of 4x squared and out of minus 3x and be left with that. So I'm taking out a common factor now. Today, it all of a sudden turned away from nice, tidy trinomials to all these little things we have to remember. Just confirm to yourself, if you multiply the x into this set of brackets, do you get 4x squared minus 3? You do. So these are the factors. I suspect that many of you know by looking that the one solution is 3 over 4, right? Not everybody. You need to write something down to see it, maybe, for some of you. How many of you can tell me what the other solution is? One is a common guess. It's not 1. It is 0. Because how do we get the x equals 3/4? You say to yourself that this factor in blue times this factor in green has to be 0. So to get the 3/4, you say, well, okay, that makes sense. 4x minus 3 equals 0. If that's equal to 0, the green thing is 0, and when you multiply it by the blue thing, you get 0, which we're supposed to get. And you solve this equation. You move the 3 over, and you divide by 4 to get this. Well, we're just going to do the same thing with the other one. This is the green factor equaling 0. Now we have to do the blue factor equals 0. So now we have the statement x equals 0, and I say solve that equation. Well, there's nothing to solve. X equals 0. You can see, by the way, that 0 will work, because if you put 0 in for x, you'll get 4 times 0 squared minus 3 times 0. You'll get 0 minus 0. Okay. Final question. Well, take out an x. Factor out an x. There's an x in each. Maybe some of you might be more comfortable writing it this way and taking the x out. Some of you might want to see that x squared term first before the x terms. If you do, and I take an x out, what do I multiply x by to get 2x squared? 2x. What do I multiply x by to get x? 1. So x equals 0, because that's one of the factors. And 2x plus 1 equals 0. When you solve the equation on the right, you get negative 1/2. When you solve it on the left, you get, well, it's nothing to do on the left. It's 0. I know that I said I would go back and show you a different way to do, I think it was C. It doesn't matter which letter it was. I'm not going to do that today. I think our brains are maybe getting full this afternoon, is maybe a good way to put it. We're back to the textbook today. So there's a smattering of different things here where you have fractions or decimals that you have to get rid of. Then there's some stuff that involves differences of squares and things like g and h where there's no constant term and you factor out an x term. I'm not going to rush around and try to get those quizzes marked before the end of the class, so I'll mark them tonight, put the marks into Power School. Again, if you're not happy with the outcome, please drop by my room near the beginning of tomorrow's lunch hour, and I will give you another quiz. Get started. Give me a second to take attendance and get my recording done, and then I'll come around and give you a hand.